Good morning, students. In today's lecture, we are going to discuss the solution of linear differential equation with constant coefficient. So here we will consider one example for the solution of such kind of equations. So let us take, we have equation d2y, just wait. Let us, we have equation d2y by dx square plus 3 dy by dx plus 2y is equal to exponential 2x, and we are asked to find the solution of this equation. It is clear that it is second order linear differential equation with constant coefficient. So for the solution, it will be written as d2 plus 3d plus 2 of y equal to exponential 2x. This is relation number 1. So here the operator d is stand for d by ds. It means the differential equation is with respect to x. Here y and x are dependent and independent variables here. So we know that this equation has two solution. That is, complete solution contains two parts. First is complementary function and second is particular integral. So you will write for CF means complementary function, the auxiliary equation will be m square plus 3m plus 2 equal to 0. We see that it is quadratic equation which have two roots. So for the solution of this equation, we get m square plus 2m plus m plus 2 equal to 0 provides m plus 2 m plus 1 equal to 0, implies that m is equal to minus 1 minus 2, that is two real and distinct roots. So CF will be C1 exponential minus x plus C2 exponential minus 2x. This is number 2. So CF is already obtained. Now we will move for the PI. Now PI can be written as 1 upon d square plus, we call it 1 upon d square plus 3d plus 2 into exponential 2x. Just recall, when you find PF, we write the function like f of 1 upon f of d into exponential x, or we can say x. Here x is equal to exponential. So in our case we have 2x. So if we put 2 here, so what we will get actually? So 2 square plus 3 plus 2 exponential 2x. So after solution, what we will get? This is 1 upon 4 plus 6 plus 2. This is 2x. So it is exponential 2x by 12. This is your PI. So this is number 3rd. So what is complete solution? For the complete solution, you can write complete solution y is equal to CF plus PI. So CF is C1 exponential minus x plus C2 e to the power minus 2x plus exponential 2x upon 12. This is your complete solution which have CF as well as PI. So I hope this is clear to you. Now we will move the next question, which is similar to this one. So what is the next question? For the solution of next question, we have equation d2y upon dx square minus 3 of dy by dx plus 2y equal to exponential x. And we are asked to find the complete solution for this equation. We also know that it is second order linear differential equation with constant coefficient. So for the solution, so it can be written like this: d2 plus minus 3d plus 2 of y equal to exponential x. This is number 1. Similarly, here capital D stand for operator, that is d by dx. Here d stand for operator, d by dx. If you are using d, suppose that you are using dy, it means dy by dx. d2y means d2y by of dx square. So in general we write d is equal to d by dx. So for CF, for complementary function, you have complementary solution, you write auxiliary equation in term of m. So it can be written as m square minus 3m plus 2 equal to 0. So what is the roots of this equation? It is quadratic equation in m, so we can write is m square minus 2m minus m plus 2 equal to 0, implies that m minus 2 plus 1 minus 1 m minus 2 equal to 0. So m minus 1 m minus 2 equal to 0. So we have m is equal to 1 minus 2, sorry 1 and 2. So two real and distinct roots, So what is the CF? So your CF will be C1 exponential x plus C2 exponential 2 of x. This is number 2. So CF is very easy. We can calculate the in other questions is the same manner way. So now PI. So what is particular integral? Now PI. So for PI we write 1 upon d cube minus 3d plus 2 of exponential x. So you know that if 1 by f of d exponential x exponential ax, so your solution is exponential ax upon 1 upon f of a. So here a is equal to 1 in our question. So if we put 1 in this part, so what we get? We get 1 cube minus 3 1 plus 2 exponential a. So the denominator becomes 0. So it is became 0. So 1 upon 0, that is infinite. So we don't approach like this way. First we decompose this operator. We can say we must convert this relation into the linear form. So we already obtained the factor of this relation. So this is d minus 1 and d minus 2 exponential is, since you know that d minus 1 d minus 2 is nothing, it is d cube minus 3d plus 2. So whenever we are getting the 0 in denominator, we must decompose the given given equation in we can say given relation in term of d into the linear form. So it is linear form. So now if we are putting 1, if we are putting 1 here, so it is become 0. So we put this part outside d minus 1 because it in getting 0 solution, 0 answer. So what is, we now solve like this way, e to the power x. So we can say that this term is making it 0. So we don't use in the right now, we just keep it outside. So what is the solution now? D minus 1, now 1 minus 2 exponential is, so it is minus exponential x d minus 1. So now we are getting minus exponential x d minus 1. This is number, I hope this is number 3rd. So again we are getting 0 here, but remember that there is a one formula, it is called if d minus lambda to the power ax, then your answer will be exponential lambda x integral of exponential minus lambda x, or here may be any function, suppose that yeah, we can say exponential x, so it is exponential x as it is. So here what is lambda? Lambda is minus 1. So your answer will be like minus exponential 1 yani exponential x integral of exponential minus due to the formula, and exponential x already given dx. So now solving exponential x, it becomes 0 dx, so it is getting dx. So what is, it is x of ex. So this is your pi. So your pi is minus x exponential x. So complete solution will be, this is number 4. So complete solution y is equal to cf plus pi. And what is cf? You already obtained c1 exponential x plus c2 exponential 2x and minus x exponential x. So this is your complete solution.